Hello everyone, good morning. Today we will be seeing the chapter thermodynamics. I want to clarify you all that I'm not starting this chapter from the beginning. It would be just a revision for those who already have completed their portions, and just before some days of exam, if you want to revise you can see this. Otherwise, if you want to learn from scratch, you need to go to some institutes or schools where they teach you. And here I'll be just teaching JE mains, so if you're going for any coaching institute, learn from them. Otherwise, you can for scratch learning, you can also refer some YouTube channels which you prefer. So it's just a revision from my side. So, okay, I'll start. Okay, first thermodynamics. I'm not getting into those basic stuffs like those types of system, or that state parameters, or the types of boundaries, or I'm not going to those. I'm just going to the important concept which are need to be revised. Okay, so first we will see concept 1, which is different processes. There are four type of processes, as we know. It is isochoric, isobaric, adiabatic and cyclic processes. For isochoric processes, volume constant. So if volume is constant, what we can infer is change in volume is zero. Say if volume is constant, so final volume is equal to initial volume, then change in volume is obviously zero, no? So if volume is constant, as we know, PV equal to nRT, already these were constant and this is also constant, so this is directly proportional to this. And we know that if A is directly proportional to B, then A1 by B1 is equal to A2 by B2. So if P is directly proportional to T, then P1 by T1 is equal to P2 by T2. Okay. Yeah, we have completed isobaric basic stuff. Actually, you need to consider many things for this chapter, like I'll be discussing in the upcoming session. So now we go into isobaric processes. In isobaric processes, pressure is constant. So if pressure is constant, then change in pressure is zero, because yeah, same logic as we see for isochoric. So if change in pressure is zero, pressure is constant, we can use the ideal gas equation, PV equal to nRT. Now pressure is constant, this is constant, this is constant, so volume is directly proportional to temperature. So B1 by T1 equal to B2 by T2. Sorry, yeah, it's V. For this adiabatic processes, it is heat transfer which is zero, or there is no heat transfer. Say you have a flask and you have some hot water in that. Inside the flask, the water remains the same as the temperature, right? It won't change. So there is no heat transfer for adiabatic systems. So in adiabatic system, we just have one formula which you need to remember, that is PV power gamma is K. This is known as equation of state. This is known as equation of state. Okay. We will learn more about this in the upcoming session. So this you need to remember this thing right as of now. Or else also it's fine. While teaching those concepts, you can see those. So for cyclic processes, when you consider a process as cyclic processes, when the initial state is equal to the final state. So say you have a process like this, where suppose you have start from this and again you are getting the same as the final state. So the state has changed and again came to the same position. So this is known as cyclic processes. As that state function is dependent on initial and final state, change in state function is zero. See, your initial state as well as the final state are same, so there is no change in the state function. So no change in the state function means change in state function is zero, no? That's all. Like state parameters I have not discussed in this session, because yeah, as I have said, it's not for learning from scratch. So you should know the state parameters such as change in internal energy, Gibbs free energy, pressure, temperature, all these are state parameters. So change in these state parameters is zero for an cyclic process. Okay, let's see in the next video. Bye.